This is the first video on a series on area. We're looking at the triangle. The formula here is A equals a half BH. B represents the base, which is a side of the triangle, and the height is drawn from a corner at right angles to the base, so the base and the height are perpendicular. This is a right angle triangle. Height happens to be one of the sides. This is an obtuse angle triangle because it has an obtuse angle here. The base again is one of the sides, and we show the height. We drop down from this corner level to the base, and if we extend the base out, we can see it forms a right angle. So the purpose of these dotted lines here is to extend the base out to meet the height and show us a 90-degree angle. The height's external to the triangle. This yellow area is calculated using only B and H. This extension of the base isn't involved at all. To show that this formula applies equally to all these cases, I've got a piece of software to demonstrate it. There's a triangle. It's got a base here in blue, B, so that's a side of the triangle, and from the other corner there drops down a height, H, making that right angle, and the green area is the area of the triangle. If I would take all the area inside the triangle to the outside, I'm going to double up the area. So this is doubling the area, and it forms a rectangle. And the rectangle's length is B and its breadth is H. So the area of a rectangle's length times breadth. This rectangle has area BH, B times H. The triangle's half of it, so it's a half BH. So a triangle is half a surrounding rectangle. If the triangle was right angled, so the height is one of the sides, it works in exactly the same way. Surrounding rectangle area BH, the triangle is half of it. This is an obtuse angle triangle. I want to demonstrate the same formula applies, that if we take this blue line, which is the base, a side of the triangle, we take this height, which is shown externally by the dotted line, height H, the area here in green is a half BH. Now to show that, I'm going to make this extension of the base length A, and we're going to look at an outside right angle triangle. So right angle triangle, down this H, right along the bottom here, and up the sloping side. So it's a big surrounding right angle triangle. Its area is base times height, but its base is the B plus the A. So the base of this triangle is A plus B, it's here in brackets. Its height is H, and it gets halved. So there's the formula applied, but the base is A plus B. If we break the brackets up, we multiply everything in the brackets by a half and also by H. We get a half AH plus a half BH. So that's a large outside triangle. To get the green area, I would have to subtract off from that this missing triangle shown by the red dotted lines. It's base A, height H. So this missing triangle here is area a half AH. And I want to take it away from the large triangle. So when I take the half AH off of this large triangle, this half AH disappears and it leaves behind a half BH. So the green area has been half BH, just like every other triangle. Base times height and half it. And importantly, it doesn't involve that A. That A is not involved in the calculation of the green area. So all triangles, area equals a half BH. So here we have right angle triangle, an acute angle triangle, an obtuse angle triangle, same area, 10 times 8 and half it. The right angle between the base and the height here, height's one of the sides. There's a base 10 and the height's at right angles to it, and here's the base 10. The height's external to the triangle at 8, and these dotted lines aren't, the extension of the base here with the dotted line isn't involved in the calculation. Now, Height doesn't mean it's vertical. If I spun this right angle triangle around, it's still 8 by 10 with the right angle between them. Could spin this one around. I've now put the height to be horizontal. Still base 10, height 8. And I've spun this one around, and there's the base 10, and there's the height given externally as 8. All these triangles are the same area and the very same calculation involved. 3 lines, write the formula, put in the base and the height, divide by 2 here, and the answer's in square units. Doesn't matter whether you write 10 times 8 or 8 times 10, you're only multiplying 2 numbers. So multiply the base and the height and divide by 2. Simple 3 lines every time. Because that's so straightforward, there's a worksheet you can get if you click the link in the description, and when you're asked to find the areas, the triangles will have a lot more figures than you need. You only need 2, the base and the height. Here you've got all 3 sides. Here you've got all 3 sides and also a height. And here you've got 4 figures as well. You only need 2. So you have to look for the base and the height being perpendicular. There they are. 6 and 8 are at right angles. 21 and 8 are at right angles. And the 10 is at right angles with this 8. The 5 isn't involved. It's just the extension of the base to show the right angle. So the red figures are the figures involved, and once you see that, the calculation is easy. Multiply the 2 numbers in half. There's a calculation. 6 eighths, divide by 2. 21 eighths, and divide by 2. 10 eighths, divide by 2. So the calculations are straightforward, but there'll be extra figures on the diagrams, so you have to pick out the right 2 figures. The other way the formula can get used is you could be told the area and have to turn it around to find a missing dimension, like a missing height or a missing base. So in this case, the area is 60, the base is 15, you have to find the height, write the formula, put in what you know, area 60, base 15, h is just left as an h, there's the numbers put in, you have to get h. Because in the triangles for the area are always divided by 2, the best thing to do to make it as simple as possible is just immediately double the left hand side and double the right hand side. So that becomes 120 on the left, and doubling the right just gets rid of this division by 2. So that's what happened there. Just get rid of the division by 2, and now you just say 120 gets divided by 15 and the height was 8. Same process in this one. Base times height divided by 2 gives you 120, and then double it up. Base times height will be 240. And there it is, solved in exactly like the one on the left. Now, there'll be 2 worksheets if you use the link in the description. So in this one you can see that 5, 12, 13, so you're given 3 sides, you only need 2, you need the base and the height. They gradually get a wee bit more difficult. These are now triangles put together, so you get 2 triangles put together and you have to calculate the area. So it's 2 separate area calculations and then a sum when you add the 2 areas. So 2 triangles, 2 separate calculations for that, and then the sum. And then this is, you're given the area, find the height or find the base, and then they've got answers with them. Second worksheet, it's 2 triangles stuck together. So you work out the 2 triangles separately and add them. Sometimes you are doing a subtraction. A big overall triangle and then a triangle taken away from it. And again, we've got the answers with them. There's also, using the same link, set of notes, and it'll cover all the videos on the area coming up. So that's on the link in the description. The next stage for this is looking at composite shapes. That's where rectangles and triangles in this case have been put together to make a new overall shape. So if you want this yellow area, it's been a rectangle and a triangle put together. You maybe see the split across here. So that is 6, just like it's 6 at the bottom, and the bottom is a rectangle, 6 by 12. Top is a triangle, base 6. This height you can calculate because the full height is 20, and on the left to the bottom of the triangle it's 12. So there's a gap of 8 between them. In other words, that 8 was from the 20 minus 12. And now you've got a triangle, you can apply half BH. The rectangle, A equals LB. Take the two areas, add them, and you've got the overall area. So that's composite shapes. This is a right angle triangle. And the same would apply for any triangle. So here, you can maybe see the split right across here to give you a rectangle and a triangle. And again, the 8 came from 18 minus that 10. So triangle, base 15, height 8, and a rectangle on the bottom 15 by 10. You show the separate calculations. And then you add the two parts together and you get the overall area. So that's composite shapes. And again, if you use a link in the description, there are 2 worksheets. It's either rectangles and triangles stuck together, or sometimes a triangle missing from a rectangle. And again, there are more figures there than you need. So there are figures there to distract so that you know what you're doing. So not all the figures are used. And again, there are answers with them. And there's a longer worksheet as well. So that's 2 worksheets in composites. Same extra figures there that you don't need. You're splitting them into rectangles and triangles. And at the end, you've got a shape where you're told the area and you have to work out a missing side. That'll be a wee bit trickier. And you've got answers. And again, you've got the set of notes covering everything. So, hope you found this video useful. The next video will be on quadrilaterals, 3 formulae, all related to the triangle. Hope you found this video useful. Thank you.